Hello everyone, that's me, I'm Patrick. I work as a technical agile coach. That means basically I work with teams actually getting better on things, especially with Spring. Spring is like my favorite technology. That's why also the talk will be about Spring AI. And I'm also involved in different community things. So Marcus outside at the Java user group booth told me, I should tell you because I'm also part of the Java user group, you should get actually there and be part of the raffle because you can win like 100 days of Java user group membership or your ticket for the next Basel One. Just that you're aware of that. Yes, good. But let's continue. My talk is actually about Spring AI. I will a bit touch on things, of course, like large language models, but I'm not going to address like difficult topics like prompt engineering, how you do it correctly, fine-tuning the models or the model selection. I also don't want to talk about the resource consumption, because that's like the next thing after Bitcoin, actually. It looks like, at least. And also the social impact and the broader sense on nonsense about AI. So I really want to talk about like how you can use it from an enterprise perspective and also with the tooling. Everything else, it's up to you, and I'm happy to discuss it afterwards in the break. So if you're talking these days about artificial intelligence, I mean, as you can see, it's a huge area. There are like different areas as well. And in the end, like when we talk about ChatGPT and so on, is we talk about generative AI. So it's not about the deep learning space where you basically have your neural networks. That still applies. You can still use it for a lot of cases. But what we are fancy about these days is really like that the AI is generating for us images, sounds, even like I recently learned about Notebook LM from Google, where they can create a podcast where two people are talking about an article, right? And that's all like this generative AI. And that's basically also like what Spring AI is covering these days. So just to show you a few examples, what you can do with AI is, yes, you know cats and the internet. No, but I used actually like the AI to generate such a picture. And isn't it lovely? I mean, I didn't even pay anything for it, and it's like crazy. I want to get now a little bit more into details what you can do with AI. So these days, actually, like if you think of use cases, we would say we could use AI as a query language to ask questions to the AI about some data you have in your systems already. So that means think of this, the prompts like an SQL for the model, and you can do something. Like here, when you say, why did the user ask for their accounts to be closed, you would go and check, or the AI could go and check the emails, the complaints logs, customer support tickets, social media, and so on and so forth. So basically, like you can, in an easy way, you can query all this data. Another thing, probably you know that as well, is like aggregation and transformation of data, summarizing text, extract bullet points, and so on and so forth. That's also like very nice with AI in general. Then it's about manipulating data, right? So that means like you can react on something, notify the user by email, maybe also execute business rules, do that like maybe with a cron job, whatever, and even like generate code. For example, like if you have some data, you can ask to create a table out of that, or like other things, as we know, that there are also tools out there which help you actually like to write code as well. For me, the fun fact with the generate code, because I'm a software developer, was like I had a week ago on Sunday. I'm not a Python person because I do Java. I'm not really fluent in that. And I just wanted basically like to measure the resources used on a Docker container with a Spring Boot app and like measure the data, store it in a file, and then actually like do some nice plots. And because I knew exactly what they wanted, it took me like 10 to 15 minutes, about 3 prompts, and I had everything generated. And I'm not a Python pro. It was really like how I wanted. I was super surprised. I expected to have it like, or I expected to use at least 2 hours to actually like solve that issue or my problem, right? And it was like, in the end, it was like 10, 15 minutes. I thought, it can't be right, but just because like the documentation about programming and so on is out there, it's easy accessible, the models know about these things. The only drawback is actually like when you ask the AI about writing code like Spring AI or LangChain4j or like other libraries, that's really bad because the space evolves so fast, there is not enough data out there which is actually up to date. So that's a bad idea. But if you have general problems, generating code is easy if the APIs are stable and so on, right? So be also aware of that not all interaction with the AI is user input. It could also be like that just like data is arriving. For example, you do some transactions like at the bank and they will basically have a model which will flag in the end if your transaction is maybe fraud or not, you know? So that doesn't mean like we always have to write the prompt actually. So we can build application and use basically the API. In the end, it's all an integration problem because the AI models, they are accessible for everyone these days. In the past, actually, like things were accessible like with C or Python library, but these days, since they exposed the REST API, it's basically you can access the REST API and that's it, right? So everyone can easily use that without actually like using special libraries for that. So in the end, actually, like REST APIs make AI accessible. And this is really like the powerful thing about that. Great. So if you think of this, how you could actually like do that is a thing that I said, yeah, I'm just going to write a prompt and I want to show you how that would look like, how to interact with such an API. And obviously you could say like, tell me a developer joke about Python. And then actually like even below you see my system prompt where I say you are a friendly chatbot and you like to place emojis everywhere, right? So I would expect a joke with a lot of emojis with this kind of thing. Another thing, as you can see as well, is I'm using an environment variable for my API key. So I don't expose it to you. And it anyway should never end up in your Git repository. And in the end, if I go and, give me a sec here, if I go and execute that for you, it's just actually the same script, believe me, we would actually like go and call the API and you would get the JSON response. So that's really like the low level thing. And as you can see now, there is some Python joke, obviously. There is some emojis. And even underneath, you would actually see like how much tokens a prompt has been using and also like how many tokens are used for the results. And then actually like both together. So basically like the token thing is very important because the models have a limitation in the context window of a certain amount of tokens. So that means like you just can put in and get out a certain amount of data in the end. And basically like what we see here is just like the statistic information. So in the end, if I would run it again, I hope I would get actually like another joke, obviously. And also what you can see here is also like the model used on top. So basically, like all the models, they have a fixed version. So you could even pin the version like very specifically, because otherwise OpenAI goes and changes the models like from time to time, and your prompts are not working anymore. So that's a thing you should be aware of. That can actually happen. Good. So that's basically like the easiest integration. So now let's talk about AI models in general. There are different ways how you could interact with such a AI model. And also, I mean, the generative AI models here. So there are input types like language, like code, and you get something out on the other side. And as you can see, there is quite a variety of input formats and output formats as well. So these days, obviously, when you're chatting with ChatGPT, it's basically text, right? Or text code, or text maybe tables or whatever. But also you could tell ChatGPT that it's, you basically like upload text and say, draw me something, and then DALL-E, another model, will actually generate an image for you. So that could be possible as well. I also have some examples afterwards where I can even like show you how to have an input of an image, and actually the model will tell you what's written on the image, right? So there is a lot of things are here possible, which is actually quite nice. And that means even like live transcribing, even probably now for my talk, would be possible with such a model in a very easy way. So if you want to see the undertitles, they're here, right? Just joking. But you could easily do that. So in the end, actually, when choosing a model, there are different things. I mean, obviously, my examples are built on OpenAI and the ChatGPT stuff. But in the end, actually, you want to see like which models fits your case. And there are obviously models out there, like, for example, Claude, which is focusing on coding. There are other models out there which are based for text, and so on and so forth. And the question is like, which model do you want to use for you? And for me, the topic here is really about like, we should learn together as a community which model fits which purpose. And there is, for example, a thing out there like the LLM leaderboard, which tells you actually like what is a good model and what not. There are others, I have a few examples here, where they even tell you like for which areas a model is suited for. And there is even a thing called the LLM Arena, where you basically as a community can rate the different models. You write the prompt, and then you can actually like use that prompt and see it, how the responses are on the different models, and you could actually rate them. So the thing is like, there is not a general purpose model out there. The question is more like, how do you choose it? And you have to be aware of that there are multiple models out there. There are open source models out there. There are like cloud models out there. There are local models out there, and so on and so forth. It's quite difficult actually like to find the right one. And these kind of things actually could help you finding the right one for your use case. Okay. So be also aware of that when you want to write something, write an application with AI, it's always about our data. I mean, who wants to have another chatbot talking about the article which were like from a year ago in Wikipedia? That's not the thing, right? So for us, it would be interesting actually like to provide our own data into it. And that's actually like also what I'm going to show you. As of now, actually, like if you go and check the documentation from OpenAI, it's basically the data from last year, which is there and the model knows about. That means everything which is newer than that, well, you have to provide in your prompt. And I mean, even you can write the prompt like this, where you say like, give me basically like the date from when you have the last data, right? I mean, that's a thing as well. You can try. It might hallucinate as well. That could happen as well. So bringing your own data actually like would be probably the thing you want to do for your company. So as we know that most of the models are trained on public knowledge and they're up to date to a certain date, that's actually like one of the challenges, right? But also we maybe do not want to expose our corporate or private data to like a US company, right? Or push it somewhere to the cloud. So maybe there need to be ways actually like how to do that. And then there is another thing actually that we need maybe also to provide some ways how they can access actually like real-time data, right? And so on. Okay, so there are some limitations obviously. And you also have to be aware of that the model itself cannot learn. It has to be trained. So that means like when people are saying something like, we sent the prompts and probably OpenAI might use it for training of the model in the future, it's really like they capture the data and then actually they will train the new model with that. But the model cannot learn in the meantime. So basically like the models are in a way stateless. And that means like everything you have been talking about with your chat model, for example, you have to send again. And that's also like what ChatGPT does if you are going to check like what is sent over the network. So for us actually, like when you are building applications, there are many ways how you can add your own data to AI applications. But most of the things which are easy for us, it's not about like training new models. That's expensive, right? That costs millions. Fine-tuning is also probably difficult if you're not a data scientist and you know how to do that. You may add some or change some parameters, yes. But the easiest way for us actually would be to add context in a prompt, for example. You're probably adding the RAG stuff. That means like you're adding vectors in the prompt to the model and basically like upload the data from a vector database. Or like the third option, which comes to my mind, is basically the thing called function calling, where the model actually says, I know you have an API in your application, trigger me that function with this data, and then actually feed it back to me so I can then continue working with your data and provide you the result. So function calling is something where the AI kind of calls your code. I say kind of because it doesn't, but it's in the API, it feels like it would. Okay, so as I said before, Java and AI, and also because of the REST APIs, that was really like the magic, why we can easily use that. So it's not like limited to things like Python or C libraries and so on. And that is actually like a huge game changer. In the Java world, there are currently like 3 libraries out there. The Spring AI, this one, LangChain for J, there will be a talk about that just like right after the keynote in the afternoon. And there is also another one which is called Semantic Kernel, where some people from Microsoft are working on some integration as well. They actually try to simplify the integration so we can just like use a client to call things and not do like low-level REST requests, basically, right? So there are like a few libraries out there. And obviously, I would say in the Java space, there are like 2 things, that's Spring AI and this LangChain for J. And I was searching basically the internet about the comparison, and I found this post on Reddit, and the guy was asking like which one to use. In the end, the answer is very simple. It does not really matter. They are just an abstraction on top of the REST API, and actually that you're choosing the right model is way more important. And I think that's actually like a great thing when you're aware of. Maybe you're using Spring AI because it's like based on the ideas how Spring does things, or you use a library like LangChain for J, which also has a nice integration with Quarkus, for example. And in the end, it doesn't matter. It's more about like the models you can use behind the scenes. So Spring AI is actually like the thing we know from the Spring world. And it basically builds on top of all these REST client implementations we anyway have. You probably know like REST template, REST client, web client, interface client, whatever. Spring has a huge history of clients for doing HTTP calls, right? And they use kind of these ideas and even add some more stuff. So if you're using, for example, Spring AI and you use like Micrometer for your observability features, for tracing and metrics and so on, it can easily hook into your Spring AI implementation, and you just get the metrics out of it. So for me, using Spring and Spring Boot and Spring AI is actually like a natural fit because it really matches the ecosystem. But there are other things actually as well which are quite nice. For example, the simplification or the abstraction, or in general abstractions we know from Spring, above of the vector databases, for example, or also their implementation on chat memory. This is actually needed when we want to provide, or when we do multiple prompts. Basically, if there is a conversation, we always have to send like the context from the whole conversation with the next request, basically. So they have quite a lot of things added there as well. And there are even things like which help us to avoid hallucination. And obviously, when a JSON document is coming back, we might want to convert the JSON into a Java object as well. So they can help us with that as well behind the scenes. So the Spring AI project is quite new. It was like created a year ago. And it was mentioned at the Spring I/O, I think, like last year. And it's pretty new. And it's inspired actually by all the Python libraries which are out there. But it's basically just like the Spring version of it. There is no final release version yet, so that means actually like we are still on milestone 3, so that means things might change. And if you're searching the internet for examples, you might see that there were some breaking changes in the past. But I would say now it's getting more stable, and hopefully with the next Spring Boot release in November, this one gets also like a major release. But you still can use it. Getting started is super simple. I mean, you know, start Spring I/O. You just like pick one of the different models which are out there. So every model has its own starter, basically, especially when they're using a different API. But it seems at the moment that like most of the models go toward the specification like OpenAI uses for ChatGPT. So it's kind of standardizing. And as well like the llama description for the interaction, it seems to me for like a second standard there as well. But even though they're like very, very similar. And the Olama one says even they support like most of the features what ChatGPT does. So it seems like the REST APIs get standardized at the moment. But anyhow, you can see like if there are models out there which have different APIs, you just use the starter from Spring Boot. You need to have a milestone repository added, obviously, because it's not in Maven Central for the releases yet. And then actually like what we do is we manage with with a BOM file, basically like all the dependencies. That helps me in the end that I don't need to provide version numbers anymore afterwards in my application. So pulling in the starter would be that easy, and the only thing I need to do additionally is basically setting some properties. And as you can see here, is I'm mapping an environment variable for my OpenAPI key. I select the model, and then basically like the client can be constructed out of that. So let's talk about the client and how that works behind the scenes in Java, some Java code here. Now Spring AI uses something which is a library which is called string template library, where you can basically write this curly braces expression as a string template. And as you also can see, we use strings with the three double quotes basically, and that means the genre in this case will be replaced during runtime with the provided value. So what you could say is it's basically something like a prepared statement, right? Where we just like exchange certain values there. So the templating engine is an additional library and additional dependencies which will be pulled in automatically. Then basically like we would execute the prompt where you on the chat client would say like chat client, you provide the prompt and then you call it and then you get the result back. And in this case basically where you say content, it's just converting the result into a string. There is also a possibility to map things to a domain object as well, right? And obviously there are also some low-level ways how to interact with things. So it's a very nice abstraction. So a thing could actually look like this in a few examples, like where you just like use this Fluent API, you're building up the user prompt. You can have a system prompt as well in the second example, right? And even on the chat builder, you could say like use that system prompt for all the calls, not just like for that single call, right? So you can actually also do something on client level which persists like over time there. Good. So let me just show an example to you. So how that would look like in code. So that would be actually like my second example here, where I have my application, and you just like can see here, Spring Boot usually uses builders. That's very important that you use not directly the chat client. The builder is actually needed that the starter can add the observability things and other things. And in the end, you just create out of the builder your instance as a Spring Bean. You can inject it basically, and then as you can see in this example, we basically map the result into a joke class or in a record down here, and we log the information. And I'm just going to show you that. Yes, that's this one. So let's hope actually it's working, and then you would see like how the interaction runs here. So just my Spring Boot app starts, and then you see basically like the results comes back, and actually like in this case I even have the prompt as a part of the response, right? And that can be mapped then afterwards to a Java class which we logged here. Good. So let's jump further. So actually like when we do a request, we usually in a request select a model because an API might have multiple models behind the scenes. You might have different kind of messages. So like user message, system message. There is also an assistant message or a tool message out there, which is part of the API. You can actually like combine some of those. And then you would actually get responses as well in the response. And of course as well also like if the whole thing got finished, with which reason and so on. And obviously also like with some statistical information. That's what we would see like if we would have a look at the API. Just to show you another example, which is actually like quite nice, is you might have an image there where you say, oh, I want to see like what's written on this. And here we are just using the regular chat client as well, but we add to the prompt basically an image. I'm using now the image and inject it as a resource. That's a Spring abstraction. And then basically I create my prompt. So I have my user prompt where I say like, what's the weather like on Thursday here in Basel? And I provide the image to that. And if I run that, the model basically like can read the information from the image. I have done that as well. So we just can run it as well here. So 05, I think. Yes. And it's exactly the same image. Basically, it's a screenshot from Google Weather from yesterday. Or from the day before, I think. Yeah, from the day before. And it will tell us now, on Thursday, the weather is expected to be mostly cloudy with a temperature around 21 degrees. Humidity will be at 79%. And isn't it interesting that actually like the model knows German and translates it because I created the prompt in English? It does that. So the model is also very great in like translating things. And even if you would say like explain something to me in Japanese, the response will be in Japanese. So that's actually nice. So you can actually do the prompts and could even specify the output language if you like to. So you can deal with such things. In the end, it's all about like data providing, as I said before. So in the business context, if you want to like search through a lot of documents, getting some information, you have quite a lot of possibilities there. And in the end, it's just like, yes, we provide context, we do the query on that, right? So for example here, think of this one. There is the prompt saying how many sports were there in the Paris Olympics, and it will tell you the things which are mentioned in Wikipedia article or where it has found it on the website. But if you go there and you tell actually like, you know what the sports were, and it just should count, then basically like your context has precedence over the data which was trained in the model. So obviously 12 is not the correct number, but I didn't provide more than 12 sports, right? Just be aware of, you can load data in there and ask the model on that, and this one takes precedence. So it's very important, and this technique is actually called like prompt stuffing, that we create like a certain description, and then actually like your application might dynamically add the context to your prompt. Right? So you would do something, you would provide some structure, you would also maybe say something like you're a helpful assistant or whatever, you probably have seen that examples, and you provide the context and you add the questions. And even if you want to have things like in a specific format replied, you could actually also say, and now please format the data in a CSV structure, or provide me a JSON structure which is compliant to a specific RFC. So you can tell actually also like the output. It's not always like that you only go about the questions and you try then to form it. You can also give examples how the results will be. Things like let the system rate from 1 to 5 to something and give examples how the rating should be done, right? And it will use this information as a context to do the rating afterwards. So in our case, if we do this, where we add these kind of things, like on the Spring AI level, it's basically that we say we have this template, like before, we add context, and then actually like we ask the question. And in the end, we just get the results back, right? So that's basically the idea. So this string templates, or this library, this engine, allows me basically to create dynamic prompts. Another idea would be actually like, because you cannot upload all the data all the time from your company, is actually like using RAG and a vector database. And that would be a thing where in the vector database, we will find out which snippets of the document will be needed to answer the question. And the thing is, in vector stores, it's an n-dimensional space in the end. And we try with similarity search, like which documents will be, or which snippets of the documents will be in the same space. So, just that you get an idea, if you think of PG vector, so Postgres has a vector API, the vector itself has on OpenAI 1,536 dimensions. So it's not three-dimensional, it's 1,536 dimensions. And that's why, because they use a model, an embedding model, which is called ADA-002. And this machine learning algorithm creates me the amount of vectors. So the vector, as you can see in the example below, is between -1 and 1. And what we do afterwards is we are going to like index the data and store the vectors in the vector database. And as you can see here, like every string or chunks of your documents get a vector in the end, which is an output with these 1,500 something dimensions. In the end, we are going to search basically like the documents which are close to a given vector, and those will be added to the prompt. And then we ask the question about those data. As I said before, this is necessary because the context window is actually limited. So we cannot upload all the information we want or we can. Out there are many different vector databases. As you can see, even Elasticsearch has an API, MongoDB, also Postgres, and many others. So there are like certain databases which provide you that feature. For our case, actually, when you go and, for example, want to index your data in a vector database, Spring AI provides you some readers, basically like to read documents. In my case, I'm providing a PDF reader, which basically splits the documents in different chunks. And then, as you can see here on the line, the vector store, we are going to add the documents to the vector store, and the vectors will be calculated. Afterwards, when I do my prompt, basically, we have our system prompt, we have our user prompt, and then we use advisors in Spring AI, which is actually about to call the vector database, and it's asking for documents which are close to that calculated vector. And that means those snippets of the document will be then added to the prompt and will be sent to the model. So that means just like parts will be uploaded. So we don't have to pay that much because we maybe upload all the document from the company and so on. And then actually like we get the result out of it. Okay. There is another thing, it's called function calling. And function calling is a nice technique where the idea would be that you tell the model that you have an API where you can get real-time information. So the idea here would be, for example, and I can show that afterwards in a demo, is that we ask, for example, like, what's the temperature in a certain location? Since the model is like 1 year old, it doesn't know about the current temperature, but we would provide like the temperature from our own API. And then basically the communication will happen with the model like the following. So basically you provide a prompt, you tell there are functions which the model could actually ask for information. The model will do some things on its own, as you can see in step 2. Then it tells, I need this additional information, tells, I would call that function in your app with these parameters. Then basically like your Spring AI is going to execute this, provides the result in the next call to the model, and then the model can work with this information. So you will have another response actually, and it means in this case there are like multiple requests forth and back between your application and the model, right? And I think that's a quite nice use case. So think of this, in Spring you can just define any kind of function, register it as a Spring Bean. It has a name. As you can see in my example, there is this weather service. And my weather service just like has some specific annotations where like I express a few things for the API as a description. So it knows like it needs to provide like the city name, it needs to provide the geolocation and also the temperature unit. And then basically we're going to call it. I'm just going to show you that in my code example. So like closing that again. So it's maybe easier to see. Oops. Here we go. So I have my weather service up here, the Spring Bean. I have like the bean name provided, right? And if we look at the weather service implementation, it's a dummy implementation. Come on, I want just to click. Yes. So I have just implemented the function interface, and what you can see here is basically there is a request coming into this apply method, and then basically we are going to read the temperature unit. And here you can see, for example, I have implemented things for Munich, Zurich, and New York. And with the New York example, I really wanted to make sure that I get the information in Fahrenheit and not in Celsius, because that's maybe the tricky part. I wanted to have the weather data in the local format. And what is actually like even more interesting is actually like what you need to provide, that it knows about it, that it has enough information. So basically like on the request object, you define like get the weather in a certain location, yes. Then we have the location, and I have provided like information. The city and country like Zurich, Switzerland should be there. And as you also can see down here, for my temperature unit, I had to actually put quite a lot of effort in that, because I had to tell them that it's F for Fahrenheit, and we also have like C for Celsius, which needs to be provided. So I had to really give some hints actually, like that the whole thing is working. And fun fact, it was working without all these hints, like in May or so this year, and then the model changed, and I needed to add some more information about getting the right results. So be aware of that. You might have breaking changes in your prompt when they go and update the model. It's not backwards compliant, right? So in the end, if we are going to run that, as you can see that in an example, I do that here with, I think it was 10. Yes. And we run it here as well. You would see then also the output of the application, and it's going to call basically like my function. The function will return some data, and the response comes back from ChatGPT. So as you can see here, New York has actually Fahrenheit there. It knows about it. But it was calling my function in my application. Think of it like if you go to the cinema and you tell the chatbot it should buy your tickets. It can do it like that, right? So you can make it part of your application that actually like the chatbot creates tickets, for example, and other things in your application. So that these kind of things are possible here. Great. So, and I see like quite a lot of use cases if you would do that in an enterprise environment. So function calling is really powerful. Good. So let's talk shortly about some AI challenges. So we have to align the responses to certain goals. That's where actually like the system prompt comes in. If you write articles, you might provide some certain tone in the language, the model response. So you could say, for example, that you're a technical writer and you want to really like write dry text. And in other cases, you may be a comedian and you want to have jokes. So the model can like get into the role of a comedian and write the answers with jokes, for example. Then actually, like, most of the models just provide strings as a result. So the challenge is actually like how to convert those into Java objects. So we need structured output basically from the model. They're like ideas where you tell, as I said before, to the system, do it in a certain specified format, then it can do that. But also ChatGPT or like OpenAI API has a JSON mode these days. So it's a bit more advanced than others actually. So that means your JSON is really compliant. And you probably also have seen that maybe if you ask ChatGPT to generate a class, it's maybe not that the class is really, that you really can compile it. There might be still some flaws in there. But if you think of other models like JetBrains AI, they make sure that the code which is generated is actually like compilable. So it really depends also here on the model. Then actually, like when we talk about the data, which is current data, we need to talk about prompt stuffing. We need to talk about your documents. That's basically RAG. And I told you before that all the models are stateless, and you always have to provide the context from the previous prompts you did. So that's where chat memory is coming into the game. And then actually, on the other hand, function calling, as we have seen before, is also like a very nice thing. And the last topic I didn't cover in my talk is about hallucinations. So you could actually like write prompts or ask other systems if the result is actually like feasible, right? And you could even ask maybe a second or a third model to validate the data. And there is a thing in Spring AI which is called evaluators, which help you doing that. So there is some APIs for this which you can implement. And I think at the moment there is just a basic evaluator in there, but it's quite simple to do your own. So as we know, artificial intelligence is going to change the world on many different levels, right? I'm not going through the points down here. But what I want to tell you is, I came across a news like late of August, where a company in the US said, we can actually do 100 million context window. So 100 million tokens in the context window. And if you think of that, it's astonishing, because that means like the Spring Framework, Spring Core, has about 1 million lines of code. Spring Boot has 500,000 lines of code. Your application, inclusive the history, is maybe less than that, right? And 100 million tokens means basically 10 million lines of code can be digested by a new model, which is actually like from magic depth. And they say we can do the 10 million lines of code. It's about like 750 novels, and this is actually huge. And what is even interesting is they got some funding actually from Google, from NVIDIA, and even from Eric Schmidt, who was the former CEO of Google. And they focus basically on software development. So I'm really looking forward to that, because that sounds crazy, that I can add my project with all the APIs from the open source libraries and the whole history into the model, do my queries on that, ask for things like how I can refactor my code, and so on and so forth. This is kind of creepy, I would say, right? Great. So thank you very much. That was my presentation, and you can get the slides on my GitHub repository with the examples as well. Are there some questions?
The Spring AI takes care of the chat history automatically, or every time you have to run it in the...
So the question is, Spring AI, if it takes care of the chat history, by default not, but you would have to add it as an advisor. So as we saw it for the advisor for the vector database, you would add another advisor which is about the chat memory, right? And you would have to do it like this. And the other thing you have to keep in mind is the chat memory with the current implementation is basically like a singleton thingy, right? So you want to have the chat history per user if you would implement a UI, right? So that means like you would implement it with some session scope, for example, to make sure that it's like separated per user, right? Yeah.
How should you specify in the prompt how this function in case of that?
This is basically... the question was regarding the function calling, and that's actually like visible in my code here, because we specify on We specify like which functions are available, basically like in the chat client. It also knows the signature of that function. So it knows about the request and the response object. It knows about this JSON property description as well. And so it can choose, right? So you're not going to force it. If it thinks it doesn't need your function to answer, it won't call it, right? So you would have to provide hints and additional information, but in this kind of thing, it's basically like clear, because I'm saying this API is made for weather information, and it will use it because it knows it cannot provide your response with real-time information. It needs something else. Yeah, great. And I think we have like 1 hour break now. Yes.